All right. So the square root of 27 I can break down into 9 and 3. And x to the 5, if you really want to, remember you can draw them all out. Or you can know that it's a 2-for-1 special and you can take 2 out and there's still 1 left, right? Either way, doesn't matter. And then this one, root 3, 1, 2, 3, 4, 5, 6, 7. Okay. So if we take the 9 out, it becomes a 3. And then we can take 1, 2 out, so I get an x squared. And then the 9 and the x's are gone, right? So under here, I'm going to be left with 3x squared root 3x. Then the next one, the 3, I can't do anything with, but I have 1, 2, 3 x's I can take out. So I can get an x cubed out front. And then I'm left with square root 3. Check that. X cubed. X cubed square root 3x. Everyone follow me to that point? Does that make sense? If not, you should be my BFF at Monday at lunch, possibly Tuesday at lunch, maybe a little Thursday at lunch, possibly Friday after school. We can be friends. I need friends. I have none. So, you know, I can hone you in through math, you know? All right. So what we have to do then is we have to go coefficient times coefficient, radicand times radicand, right? So we're going to get 3 times 1, which is 3. X squared times x cubed is actually x to the 5. Because when we have 2 bases and 2 exponents, we learned in grade 10 that we add them. Big old grade 10 rule. Then, what did I tell you when we go square root 3x times square root 3x? The square root sign goes away and we get 3x in brackets because they match. So our answer is 9x to the 6, because we had exponents, and we had to follow behind with x has to be greater than or equal to 0, because we had an x under the square root, didn't we? It doesn't matter that the x is out now. The fact that we had an x under the square root, we have to make it greater than or equal to 0. Yeah?
If we don't like break that on the x will be wrong.
With restrictions? Yeah. Because if not, you could end up with a negative underneath that square root, which is a problem. So you always have state restrictions. And it's good practice for next year. Because this year, it's always 0. Well, until we do solving. Next year, it won't be. All right. The next one doesn't have any variables or letters, right? So I don't have to state any restrictions. Do you agree? This and this. All right. So for this one, though, I have something and then a binomial. So I have a monomial times a binomial. So I distribute. Well, first I would check if I can reduce, because that's the first step I do always. Can I reduce any of them? The answer is no. So if I can't reduce them, then I go right to multiplication, right? But I always try and reduce my radicals first, always. So square root of 15 times 3 root 5, coefficient times coefficient, radicand times radicand. So 1 times 3 is 3. Square root 15 times 5 is, what is it? 1.60 again, guys. It's an addiction. 75. And then minus root 45, right? Then can we reduce? 75 becomes what? 25 and 3. And the 25 comes out and it's a 5. Then this cancels off and I get 15 root 3. And often, I know this is weird, I usually like finishing an equal sign then going to another one. But I'll do these 2 steps in order just so I don't forget when I get to the next step what I was doing in this step. Right? So I don't get all muddled up. So I usually do the 2 steps together. I know it's weird. But it's just so that you don't make mistakes. And then this one is going to be 9 and 5. The 9 comes out and it becomes a 3. 9's gone. Minus 3 root 5. Now what do I do in the next step? Trick question. You don't do the next step. You just Circle it or box your answer, right? That's it. That's all. You're done. Move on. Because I can't add or subtract things that don't have like radical, right? That's my rule. So every single lesson we've done has used the previous lessons in it, correct? So if you're still struggling on a previous lesson, you need to come in and get help and practice and practice and practice and practice until you stop struggling. Because if you can't do a simplification, you can't do any of them. If you can't do addition and subtraction, you often can't finish a multiplication. If you can't multiply, you can't do a division. They all like feed off of each other, right? All right. Number 3, what did I tell you to do when you see it squared on a bracket? Cross it off and repeat it immediately, so you don't do that wrong. So I immediately go, no thanks, and then I go 4 root 3 plus 3 root 5. Then in polynomials last year, you had to distribute in polynomials last year. It's this big long lesson. Sometimes you had a bracket and a number in front minus a bracket and a bracket. Like it was extensive. Grade 10 polynomials is very extensive. So you learn to distribute in grade 10. Well, I reminded you that when you distribute a number in, or anything in, when you hit an end bracket, you have to stop, right? You're not allowed to keep going. Once you hit an end bracket, it disappears, right? It's like magic. The number goes away. We agree? Remember I told you that? So we're going to do that again. Agree. So I distribute the 2 in. I hit an end bracket, and the 2 stops distributing, right? It disappears. It just gets inputted. Remember that? So I would check if I can reduce anything, but I knew I couldn't because they're 3s and 5s, which you can't reduce, correct? So then I'm going to get 2 times 4, which is 8 root 3, plus 6 root 5, close bracket, and then I rewrite this one. Then I have a binomial, so 2 terms, because the plus sign makes a different term. So I have 1, 2 terms, 1, 2 terms. So I have a binomial times a binomial. So I need to distribute, correct? What's a helpful acronym to help you distribute a binomial times a binomial? FOIL. So first, outer, inner, last, right? Do you have to follow FOIL? No. You literally just need to distribute them all. It's just one that you can maybe remember not to remember. So we're going to go first times first. So 8 times 4 is 32. And then root 3 times root 3 is 3 in brackets. Right? Then we do the outside ones. 8 times 3 is 24. Root 3 times root 5 is root 15. Then we do the inside ones. 4 times 6 is 24. Root 5 root 3 is root 15. And then we do the last. 6 times 3 is 18. Root 5 times root 5 is 5 in brackets. So, then we can put together what's multiplied. So 32 times 3 is 96. 24 root 15 plus 24 root 15 is 48 root 15. Some people try and make it go away. I don't know why I'm drawing a T. Sometimes my brain does what it does. So plus 48 root 15. The root 15 doesn't go away because we need common radicands to add, right? It's only when you multiply. And then 18 times 5, 90. So we get 186 plus 48 root 15. Can I reduce the root 15? Nope. So what do? Box it, and I am done. Then came to tears, like people were dying inside a little bit. Remember, we did this on Friday. Remember, you write notes for a reason. Remember, I let you look at your notes for a reason, right? So on your unit test, you can't look at notes. But on your quizzes, you can totally look at notes. Why? Because sometimes you just need a little bit of a reminder to be able to do something. So the very first thing we're going to do is try and reduce. That's what I said I always try and do anyways. If you don't go that route, it's fine. You just might end up with some really large numbers and then try a little. So we don't want that. So I'm going to reduce first. So x is going to stay in x. an equal sign because these all equal. Root 18, I'm going to break down into 9 and 2, and then x, x, x. The bottom, 4 root 6x, nothing. Can't do anything about that. So at the top, I'm going to take the 9 out. It's going to become a 3, and then 2 for 1 here. Take that out, it becomes a x, so that cancels. So on the top, I'm left with x times 3x, which is actually 3x squared root 2x over 4 root 6x. Remember grade 10 times that? Now the rule I told you, the biggest issue is that we can't have radicals in our denominator, right? So if you ever stop on a question while you still have a radical in the denominator, you have not gone far enough. People will be like, I don't know when to stop. If you have a radical in your denominator, you should not stop, right? You stop when the radical's gone. Now, I told you, this is just a monomial, right? There's not like 2 terms or anything down there, correct? It's just 4 root 6x. So my problem is the root 6x. And how can I get rid of a root 6x? Yeah. Times by root 6x, because root 6x times root 6x, poof, becomes bracket 6x, right? So I don't have to multiply by the 4. The 4 is not my issue. The 4 is absolutely fine. It's the root 6x that's my issue. So I'm going to multiply by root 6x. And if I only multiply by the bottom, remember when I was giving you that fraction rule, like when I went to 1/4 of a pizza and I times it by 2, I would actually get 2/8 of a pizza and it would still be the same pizza because I multiplied the bottom by 2. I had to multiply the top by 2. These are just fractions with crazy radicals and variables, right? So if I times that bottom by root 6x and I don't do it to the top, I've totally changed this expression. Totally. So I have to multiply the top as well. So I'm going to get 3x squared times 1. Because remember when a radical doesn't have something in front of it, it has a 1. So you can write the 1 if it helps for you. 3x squared times 1 is 3x squared. And then root 2x times 6x is 12. And what's x times x? X squared. On the bottom, I'm going to get 4 times 1, which is 4. And then root 6x times root 6x is 6x. In brackets. So we've gotten rid of our problem. Now how do I know when I'm supposed to stop? Well, you stop once, your radicals are reduced as much as you can, and there's nothing else you can cancel on top and bottom in the front coefficients. So I know that 12 I can break down into 4 and 3. And then x squared is just x and x over 24. Now, no. So, the 4 can come out as a 2, and these x's can come out as an x. So on the top, I'm left with 3 times 2, which is 6. X squared times x is x cubed, root 3 over 24x. Now, the 6 and the x cubed, what's connecting them? What actual operation is connecting them? Yeah. Multiplication. And if we multiply, we can put a dot, we agree, but we can also put brackets around each of them. That means multiplication as well. So why do I put brackets? To remind myself that I can actually simplify these separately. So the 6 would be in its own bracket, the x cubed would be in its own bracket, the 24 and the x could technically all be in their own brackets, because when a bracket touches a bracket, that's multiplication, we agree? Bracket times a bracket is multiplication. Now, because they're both coefficients and there's no plus, are there any plus or minus signs anywhere in here? If there's plus or minus signs, which today is going to happen, we won't be able to do this. But because there's no plus or minus signs, this is one term and this is one term, we agree? If I can take something out of both of them, it can come out. So, out of the 6 and the 24, I can take out a 6. So the 6 divided by 6 is a 1, and the 24 divided by 6 is a 4. And then the x cubed and the x, I can take a 1 out. So this x cancels off, and then this one I'm left with 2.
No,
Way. So that's going to be x squared root 3 over 4. And we have to follow behind with x has to be greater than or equal to 0 because there was an x under the radical, right? Now the last one, I didn't tell you guys to do this, but there is a way that you were taught in grade 10 that you can actually simplify the last one quicker. So I'm going to show it to you. It was taught in the radical lesson. Okay. He was doing it right. Okay, so we're on the last one here. Now, in grade 10, you were taught this. If you didn't spot this right off the bat, no big deal. You're going to multiply by root 70, and root 70 are really large numbers, which I'll show you still works. Okay? But in grade 10, you were taught that if you have a radical over a radical, there's no plus or minus signs here, right? This is just a radical over a radical. You can actually write them under one whole radical and reduce them first. So I'm going to show you that first, then I'm going to show you the way if you didn't notice it. So what you can do is you could write this as 5 over 7 square root 21 over 70. And we only did this in grade 10 if doing that would be able to like cancel something off. So what could I take out of 21 and 70? I could take a 7 out of both, couldn't I? Yeah. So if you didn't spot this, no big deal. I'm just showing you another way. 21 divided by 7 is 3. 70 divided by 7 is 10. So then I could actually rewrite this split up again. I can go 5 root 3 over 7 root 10. I can split it back up. You can only do this if you have a monomial over a monomial, though. Nothing with plus signs. If there's plus signs in the top or plus signs in the bottom, you can't do this. Okay? Which this one doesn't have. Then I can multiply by root 10. If you didn't go this way, no big deal. I'm just showing you another way. And you would get 5 root 30 over 7 times 10. So it would be 5 root 30 over 70. Can 30 reduce? Can the square root of 30 reduce by anything? 4 can't go into it, 9 can't go into 16, no. But the 5 and the 70 can. What's 70 divided by 5? $70 divided by 5. So we could take a 1, and make this 1, make this be a 14, and we could get root 30 over 14. I left a lot of space here because I want to show you if you didn't notice that, which I'm assuming most people wouldn't have. Okay? David's spidey senses kicked in and made him do it that way, which is fantastic. He didn't think it was even right. But you can. The other way, which I'm assuming most people did, 5 root 21 over 7 root 70. Can I break 70 down into anything? No, so we're just going to deal with big numbers if we do it this way, which is not the end of the world. So we're going to multiply by root 70. And we're going to get 5 root, what's 21 times 70? 1,000, sorry?
470.
470? And then we get 7 times 70 on the bottom, right? Which is 490. This is just 49 and the 0. Okay, 1470, what can I break it down into? It's going to be 30 and something. Yeah?
49 and 30.
49 and 30. So remember, you work your way through the chart, right? You do 1,470 divided by 4, 9, 16, until you get one that works, right? Now, the 49 can come out and be a 7. So I'm going to get 35 root 30 over 490. And then I can divide them both by 35. Now, so we can take a 35 out of both. What? Why did I do that? Why did I take a 35 out of both, get 1 and 14. So it's going to be root 30 over 14. Same answer. So if you don't spot that, are you like done? You can never get the answer again? Nope. Same answer. Okay? You're going to flip to where you left off in your notes. We're doing radicals, but this time there's going to be a binomial in the denominator. We need 2 terms. All right. So, rationalize each denominator. What does that mean? It means make it not be a radical. Okay? A rational number is one that doesn't have non-repeating, non-terminating decimals. That would be irrational. If you took square root 3 and you actually square rooted it, it would be a decimal. That would not repeat, not terminate. It would keep going. So we want it to be rational, like a number 3 or a 5 or a 7 or something nice. Okay? Basically, what does that mean? You never have a radical in your denominator, in your bottom. So what is my issue? The very first thing I'm going to do with A is I'm going to say, can I reduce anything? Right? That's my first thing I'm going to do in any of them. Adding, subtracting, multiplying, dividing, because it will make my life easier in the end. Maybe more steps, but easier. Right? So can I reduce any of that? Nah, nothing I can do. So I have a root 3 in my denominator, which is my issue. How do I get rid of a root 3? Yeah. Times by root 3, because root 3 times root 3 is brackets 3. Right? Over and over and over. We're going over that hundreds and hundreds of times. So, multiply by root 3, and what I do to the bottom, I have to do to the top. Now, for your own welfare, I'm going to put the top in brackets, because up until today, up until this very moment, I've always gave you a monomial over monomial, correct? Monomial over monomial, right? But now I have a binomial. So I'm going to have to make sure to take that root 3, and when there's something in brackets with something outside of it, whether it's on the left or it's on the right, you have to distribute it in to get rid of the brackets, right? The moment you distribute, the brackets just poof, go away. We agree? So I know often it's more confusing when the number's behind, because you're like, wait, it has to be in front. Could you move it in front if it made your heart sing? Sure. These are multiplications. Root 3 minus 1 times root 3 is 2 multiplications, correct? And remember we discussed this? Multiplication can switch. They give us the same thing whether we move them. So if you're someone who's like, I literally, Lepp, cannot distribute this way. Like this is just, my heart does not sing. It makes me super angry. And I get, then move it. Put it in front. Then distribute it. It doesn't matter. Multiplication can move, right? You do you. You do what works for you. Okay? I'm going to write them behind because that's just how I do it. You put it in front because it's easier to distribute, please. Go ahead. Okay? So, next thing is to distribute the top, which we didn't have to do last time because it was monomials. So, root 3 times root 3. What do we get? 3 in brackets. And we get an equal sign. We agree? So we get a 3 in brackets. Then we have to distribute. And we have to distribute because there's a minus sign in here, right? What's negative 1 times root 3? Negative 1, root 3, right? When you multiply a coefficient times a radical, you just get the two slammed together as a lovely little radical. So we're going to get negative 1, root 3. And then what's root 3 times root 3? 3. Now people get to here and you're actually done. And then you guys go like simplifying crazy and totally destroy your answer. If this is an answer, it's beautiful, it's lovely. I can't go any further, but you guys do. And somehow you get like root 3 is your answer. And then it's just destroyed. And I'm like, if you would have just stopped here, we would have been right. Okay? We have to understand why. So if it's just a 3 by itself with no minus sign or whatever, I can write it without the brackets. If there's a 1 in front, I don't actually have to write it. But I'm going to continue to write it to prove a point. And then a 3 in the bottom. Now, I told you before, we could cancel off if it was in the top and the bottom. We agree? What are we actually doing if we're canceling? We're taking something out of every single term. Every term. And terms are separated by plus or minus signs. We agree? Until now, we didn't have terms. We just had a monomial over monomial. So if we could cancel off both, we were golden. Correct? Now, this actually has how many terms if we count all of them? 3. There's 1 here. 1 here and 1 here. We agree? I'm going to make them underlined in red to prove a point. So this is 1 term, this is 1 term, and this is 1 term. We're following? We understand that? This is the huge part. You guys can usually get to here and then destroy it. That's what you do. I don't want you to destroy it. I want you to get the right answer box. Now, how's the only way we can get something out of a radical? Can we ever just cross it off and cancel it off with something else? Never. It's illegal. You should get like a ticket and you should have to pay me in a bag of chips or something like that. So we can't just cross this off with something else, right? We can't. The only way we can reduce a radical is if we can actually take something out of it or we multiply it by itself, right? That's it. So our very last step after we've done all of this is we look at the coefficients of each of these and we say, can we take something out of the coefficients? I don't give a hoot what's under the radical sign. I don't care, right? Because I can't cancel anything off of it. If I go and put a line through it, I'm doing something illegal and I have to stop myself, right? So some people will say, I can take a 3 out of each of these. Can you? No. You look at the coefficients. I have a 3, I have a 1, I have a 3. Can I take anything out of those? A 1? If you're taking a 1 out, does that change anything? No. Can't do anything. I box it. I move on. That's going to be the hardest part for you. Stopping. Not doing something illegal after and destroying your beautiful answer. Okay? B. B has a root 6 underneath. A 3 root 6, technically. But do I do anything with that 3? Is the 3 my problem? No, the root 6 is my problem in the denominator, right? So what am I going to multiply them both by? Root 6 and root 6. Could I do the 3? Yes, you're just going to have to cancel more off at the end. You're making your life worse. Okay? So when there's a monomial, you just multiply by the root. So you try that one. Okay. So for B, we have to multiply by root 6 and root 6. So we're going to get 6 root 2 times root 6. It's 6 times 1, which is 6. Root 2 times root 6 is 12. Plus 2 times 1 is 2. Root 6 times root 6 is 6 in brackets. Over 3 times 1, which is 3. Root 6 times root 6 is 6 in brackets. Now you know you did good if in this step your denominator doesn't have a radical anymore, right? If your denominator still has a radical, you either made a mistake in your multiplication or you totally picked the wrong thing to multiply by, right? Because the radical should go away in that step. Now the root 12 I can reduce to what and what? Yeah, 4 and 3. The 4 comes out and becomes a 2 plus 12 over 18. And so I get 12 root 3 plus 12 over 18. Now remember I told you, and honestly, if it makes it easier for you, because this is where people go wrong, highlight each term separately. Put a highlighter on them, right? So I would go like my 3 things are highlighted. Now I know I have 3 terms, and if it can come out of the coefficients of all of them, yay. If it can't, I'm done, right? I box it, I move on. It's going to be your hardest part, is moving on when it's done, or reducing when it's not done. So I have a 12, a 12, and an 18. Can I do anything to those? Yeah, what can I take out?
Yeah, 6.
A 6. 12 divided by 6 is 2. I still have a lot of fun. And 12 divided by 6 is 2. And 18 divided by 6 is 3. So my actual answer is 2 root 3 plus 2 over 3. And if you stop at this previous one, you're going to lose 0.5 because you didn't reduce it. Okay? Did I cancel off the 3 in here at all? Do I care what's under that radical? No, it's coefficients. And I take it out of every coefficient. And sometimes it makes your life easier if you just highlight each term because it draws your eyes to that I need to take it out of 3. Or maybe later on it's going to be 4. Okay? This one I'm going to multiply by x. But before I do that, I can reduce this 18. So I'm going to do that first. If you didn't, no harm, no foul. You'll reduce at the end. So 18 I can reduce. I'm just going to do it up here. So 9 times 2 times x. And the 9 comes out and it becomes a 3. So I'm going to get 3 root 2x. On the 8, I can go 4 times 2 times x. The 4 comes out and becomes a 2. So minus 2 root 2x. By doing that, what did I do? I actually have like terms, don't I? Can I not just put them together and I have a monomial? Yep. So now I have 3 root 2x minus 2 root 2x, and I just have root 2x, or 1 root 2x, right? Did my reducing become a heck of a lot easier? Yeah. Now I can just multiply by root x. If you didn't go this route, you could still have the same answer, right? Don't go crazy and erase and everything. So, square root x, square root x. So I'm going to get root 2x times x, which is root 2x squared over x. X squared can come out as a x. So I actually have x root 2x over x. And I'm going to look at my terms. One term, two terms. I don't have any more terms because there's no other plus or minus signs, right? Can I take anything out of them? What do they both share in common? An x. Get off highlighter, that would help. Oops. Let's just root 2. You try this one. It will not do that. Try C. All right. Root 2x. Oh, I want to reduce this one first. Stop the madness, Lepp. Reduce. Come on. Who are you? I don't know. Shameful. I don't even know what I did there. Like, how horrible. I'm just terrible. I don't even know how to live with myself. But I fixed my problem, and now I can live longer. Had I not reduced the root x, would it have, like, destroyed my life? Nah, you just reduce it later, right? Don't go, like, all aggressive on yourself like I just jokingly did. Just fix it. All right. So we have 2 root x plus 2 root 2 over root 2x. Life can't get much better than this. This is happy times for me. All right. Root 2x, brackets. And so we get 2 times 1 is 2. Root x times 2 root x is root 2x squared. And then that can come out as an x. Gone. Plus 2 times 1 is 2. Root 2 times root 2x is root 4x. The 4 can come out as a 2. And it's gone. And then root 2x times root 2x is 2x. We're happy. We multiplied by the right thing. The radical went away. If it didn't, we got problems. So we have 2x. So in the next step, we have 2x root 2 plus 4 root x over 2x. Can I put those together? I have a root 2 and a root x? No. Addition, subtraction, if you like radicans, right? So then I go to my little highlighter, which brings me great joy. I'm going to make it be blue. Those are my 3 terms. Is there anything I can take out of all 3? I moved that thing over. Come back. No. Really? A 2. Because remember, the 2 and the x are what? They're multiplied, correct? So I can actually separate them. I don't have to take out like an x as well. I can take out the 2, or I can take out the x's, or I can take out both. But they're not attached by plus or minus signs, so I don't have to take them together. They're kind of like friends attached, but they can separate. Okay. So, pen. Talk to myself to remind myself. I want a pen. Okay. So, we can take a 2 out of here, she gone. We can take a 2 out of here, we got a 2. Take a 2 out of here, they gone. And we're left with x root 2 plus 2 root x all over x. Happy, awesome, box and x. Okay? Literally taking this lesson as a snail's pace, because this would normally be taught in one day. We have a monomial or monomial, or binomial over monomial, or a binomial denominator, and I'm doing it in 3. So we got to keep up with our homework, right? And if we don't know what we're doing, we're asked the question. And what we have left is solving. I just ripped my paper. So sad. So that's your homework. These two are based off of today.
This is for the whole week, right?
Child, please. That is literally 7 questions.
I know.
7 questions.
Like torture.
Who brought him in here? Who allowed him in?
I actually requested to be in this.